Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
So in the previous video tutorial, we spent most of our time working in our studio, and I said it was just basically to show you that it's possible to bring Earth Engine data in our studio and perform all sorts of nice things like 3D correlation, line graphs, regression, all sorts of things. Very basic stuff, and obviously one can take it to the nth level in our studio. Again, there's very little end in sight in our studio for what we can do, either working with the images itself or working with the time series. Our studio allows both to do, work with rasters, vector files, point files, work with the data in time series format or in cross-section format, or beautifully you can do also work in panel format. So there's a lot we can do in R, and we covered that basically in tutorial 79. So in this tutorial, what I want to do is to work in QGIS. Sorry, not QGIS, GeoDa. I'm not sure how many of you are familiar with GeoDa, but I find GeoDa to be a very, very neat little program. Obviously, it's not as powerful as QGIS or as powerful as RStudio, but still it's a very neat little program, and I like working on it because there's certain features in GeoDa that I just simply adore. And when I do an consultancy work, I always reference GeoDa. I always bring something of GeoDa into the fold. Okay, so as I said, remember it is Earth Engine everything starts at Earth Engine. And you can also finish things in Earth Engine, but it starts in Earth Engine. From there, it normally takes a tour to QGIS, and from QGIS, it normally goes into Excel and RStudio for time series work, for data work, and from QGIS, I can take it to GeoDa for some activities in GeoDa, so some features in GeoDa that I found it to be better than in QGIS and stuff. Okay, so let's quickly do a little bit of, see in GeoDa what we can do there. So I've downloaded GeoDa, so it's got this little sign here, and you just go to Google and just search GeoDa, G-E-O, capital D-A. So Geo for geography, and DA for data. So GeoDa. Let's see if I can get, there we go. That's how you spell it, GeoDa. Okay. So it's quick to download. It's free to download. Easy peasy to download and stuff. It's very good for vector analysis, working with vector data, either in polygon shapes or in point shapes. It can do a bit of work in raster, but I don't like to work within a raster. I still believe that QGIS is best sorted for raster. So raster I stay. But in QGIS, I normally, as a matter of course, convert everything into polygon vectors or to point vectors. And both the polygon and the point vectors I can work in GeoDa. So here is the 100 points that I've generated in Earth Engine. I remember this is the 100 points that we generated in Earth Engine. We saved it, and then in Earth Engine and in QGIS, we populated this data set, or Excel as well. We populated this data set, and I saved it. So if I go into my QGIS, there it sits, this snow, terrain, climate points. I basically just right click on it. I export. Remember where I exported as a CSV to be used in RStudio, in Excel and RStudio. I now will just save this as a shapefile, okay, as a shapefile. So now the same point vector that I've got in QGIS, the one I save as a CSV file to work in Excel and to work within RStudio, because I'm looking for the data, and then I save it as a shapefile, specifically a point shapefile, a point vector file, to work in GeoDa. Okay, so that's where it comes from. So I've got my GeoDa, so I basically just go to File, And okay, so it's closed here, but let's just close it quickly. I go to File, and you'll get this little backdrop. Okay, and here I just go click on this little button there. I can drag and drop, or I click on this little button here. I say I want to see. You can see there's all the packages that it can include. Okay, and I go to Shapefile, and it is called what was it called? Snow terrain climate points. Let's quickly just have a look and see. Snow terrain climate points. Yes, so it's snow terrain climate points. And I press OK, and there it sits. And there's your data. Data is now in GeoDa. Okay, there's all 100 points. Now, there's a whole lot of things. On the top is all your ribbons with all the things that you can do. It's basically into a couple of, call it categories of stuff. This is just open, save, close. This is your table, your data itself, and this is the weight manager. Now, the weight manager is quite important when we do certain things. These are basically 3D figures and images and graphs that you can do, still more graphs and things. And then here to the end is the correlation, the clustering, and here is the regression stuff. Okay, so there's a whole lot of things that you can do. It's all basically put up there as well. But the first thing first is, let's open it up a little bit. Let's make it a bit bigger so it covers the whole window, so it's a little bit bigger. So first thing is I just right click on any place here, just right click. And then you see there's a whole lot of things you can do here. There's displaying of it. You can display it either as a quantile, you can as a percentile, as a box, a standard deviation, unique values, natural break, equal intervals, customs. There's a whole lot of things that you can do there, specifically in terms of the centers, getting the mean centers and adding those. And these are obviously interesting when I have polygons. I have points, so adding mean centers to the table, it's already there. So there's not connectivity I can do. And then the rates I can do. There's a whole lot of things you can do. So let's just quickly go natural breaks. I'm going to go, let's say, 8 natural breaks, and then it asks you the variable itself. Let's say we're going to do snow, and I'm going to do the snow, which is the sum. Press OK, and voila, there it goes. So it gives you your 8 breaks, 1, 2, 3, 4, 5, 6, 7, 8. It gives you the value of snows, but interesting, it also gives you the number of locations within that range, within that bracket. Okay, so there's your high locations, high-low snow locations. You can see it's located there. There's very little snow, if any snow locations there. So no snow locations, less than 1 is 8. Between 1 and 10 is 49. Remember, this is cumulative. So, so that's why you have to really look at this side to go and figure out any snow. So bigger than 374, there's 7 locations. And you can see they're basically located there. Okay, so you do that. You can also, for example, if you right click again on it, you can go, let's say I change the theme. I go to, let's say to box map hints 3. Okay, and then it goes there. You can see now it gives you outliers. So it indicates there between 25, less than 25%, and then upper outlier, there they are. Again, it's on the upper outlier. You can see there as well. So there's different ways of presenting the data. Sorry. There's different ways of presenting the data. Obviously, you can export everything. So copy legend to the clipboard, and you can just save image or copy image to it. So all of these things are exportable, savable, etc., etc. So that's just the initial part of it. You add the shape file, the point shape file. You right click on it, and there's a whole lot of things you can do with it in that. Okay, select neighborhood is not going to work because we don't have a weight file. And that's the beauty of GeoDa, is when you start working with weights. And that's really when GeoDa comes into play. That spatial interaction, that spatial relationships. That's what we want to look at. Okay, anyway, so right click, and there's a whole lot of things that we can do there. Rates, let's have a look at the excessive rates. Okay, so we're not going to do that now. You can choose the 2, etc., etc. Okay, anyway, there's a whole lot of things that we can do there by just right clicking it. But for me, what's interesting is when we get to, okay, so just quickly go there. That's a table. That's a table that we've already got. You see there is the sum snow average, snow medium, snow coefficient, max sum, etc., etc. And then there is the elevation and the hillside, the aspect, the terrain, etc., etc. Okay, so there's the standard data. I think you are familiar with it now, etc. Okay, so let's have a look at, so that's it. In terms of the weight manager, what we want to do is create a neighborhood weight matrix. Now, when you work with polygons, it's actually because you're looking at touch points and neighbors and things like that. So for it's not ideal for point data, but it's still doable. Okay, so we click on, and you'll see where, for example, when we do more on eye statistics or clustering or for example, spatial regressions, then the weights manager becomes quite important. If you don't understand, don't worry about it. But yeah, so when we're looking, weights basically tell you that near things are more relevant than far distance things. So for example, I would have a bigger relationship with my neighbor than with somebody that stays 10 blocks from me. So that's what the weights manager is. It basically tells us a spatial relationship. Nearby things have a bigger relationship than far distance things. Okay, same with gravity model and things like this. The closer you are, the stronger the relationship. The further you are away from one another, the weaker the relationship. So that's what we're doing when we're doing the weights manager, when we work with weights. Okay, so there's different, so we're just going to say create. We're going to create a weights manager. You select your ID variable. Normally there is, you just don't want to use any of this, so you just say add an ID, and you just say that. So we just generate an ID, not any of the things that, so we're going to use that ID. Now there's different ways of doing the weights. We can do the queen, the rook, or we can do a distant weights. Then from Excel, so that gives you a clear. So within a certain distance, you are, let's call it neighbors. If you're outside distance, outside that, you are not neighbors. Okay. But in general, I prefer to work with a good old queen continuity, and I work with order 1. Okay, you can do all of others, try them, have a look and see how it works, what the difference is, etc., etc. I work with the standard queen continuity. Okay, that's my preferred option, as I said, but just remember there's big differences between them. So it's always good to generate 2 or 3 different weight matrices to see whether there's statistically a difference in the results or not. So just bear that in mind. Obviously, with when we work with points like we have, it's good to work with distances. And as I said, you specify here the distance and neighbors, how many neighbors you want to kernel. So go and have a look at it. But let's, for example, say queen continuity. I create. We save it as a weights file in a GAL weights file, and we just press save, and it says it was successful. Blah blah blah. I'm going to close this now. Okay, so we've got it. Now, interesting in here, let's make it a little bit bigger. We can now go and have a look and see about the connectivity map, the histogram. So there's a couple of things. So we're going to go and histogram. So you'll see there's the number of neighbors. How many of these points have 2 neighbors? What's it? Just 1 or 2 points. Most points have 6 neighbors. And then, as I said, you go, how many have 12 neighbors? Only 1 again. So you can see most of these locations have 6 neighbors according to the queen method. Okay, it will be very different if we do the distance or the rook, or it obviously will be different. But I said the queen, you can't go wrong normally with the queen. Most people use the queen. In our case, it's 6. Then we can go to the connectivity map. And you can say, click on one and say, there's your neighbors. Okay, so there, it will highlight its 6 neighbors. 1, 2, 3, 4, 5, 6. If I do this one, it will highlight its 6 neighbors. We do this one, it will highlight its 6 neighbors. Now, what it says that is that it has a more stronger relationship with them than the others. So if you fall within that 6, you'll have a strong relationship, meaning you are close by, Therefore, you have a strong spatial relationship. If you're not part of the 6, you're far, and therefore you have a decreasing, an inverse relationship with transport. So the further you are away distance, the weaker that the relationship becomes. Okay, so I hope that makes sense, and you can obviously connectivity graph. You can see there how they're connected with one another. Okay, now this is obviously we can bring this weights matrix into RStudio. Okay, so either in RStudio we can create this, or in RStudio we can just upload this district weight matrix, depending how comfortable you are with the coding. It's up to you. Okay, so yeah, so that's the weight. So we use the weights. You'll see now when we use the weight. So that's very, very handy of GeoDa. It's of the programs that we've done so far, this is the easiest way to create weight matrix. I'm certain we can do that in Erath Engine or in QGIS. When I said we can, for sure, I know we can do it in RStudio. But I said here in GeoDa, it's very simple. It's just tick, tick, tick. You don't have to code. You don't have to do anything. It's just tick, tick, tick. So beautiful, 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 beautiful. Okay, so that's that. Now we can go into these ones, which is maps and rights. We've done those ones. We can go into cartograms and stuff. So let's, for example, say we're looking for the sum, and our other variable would be, let's say, maximum temperatures. And we're going to go to the mean of maximum temperatures. So those are my two variables, and there we go. Okay, so you see here, there's a big clustering around here, and otherwise there's very little. So this is now where there is high snow and low temperatures. So we can do that. There's a map movie. We can do category editor. There's histograms that we can do. Let's say that's histogram there. We can do that and stuff. There's some box plots that we're going to throw around. There's our box plots there. And then we get to more 3D type of charts. There's scatter plots here. So we can do, let's say, snow, double click on it, and let's say wind, and we're going to do it in wind speed medium, and there we go. It shows you there's the relationship between the two. Nothing much. So we can do that. Then we can go in a bubble plot. Here we have a whole lot of things. So let's say there's the sum. Our snow is sum. Let's say now we can add our y-axis, let's say, is we know that slope. No, why? Where's my slope? Keeps on hiding. I had the slope here somewhere. Let's have, which one would be the slope? I think it's terrain 2. Let's quickly go into here. There's the terrain. My slope is here, band 2, so it's number 2. So that's my slope. Let's go back. Slope is terrain 2. So that would be my y-axis. The size of it, of my bubble, would be, let's say, minimum temperatures. Where's minimum temperatures now? Minimum temperatures is that one. Oops, sorry, not yet. Minimum temperature is that one. And then a bubble color I'm going to do as the elevation. And I press OK. And there it is. So that gives you a nice, so yeah, so you'll have to go and play around with these ones and see what they are. The nice thing is if you click on them, they'll tell you which location it is. If you click on the blue, it is those locations, and that is that location. So that's the beauty of this, it's interactive. So let's quickly go again. Let's do that. There's a dark blue one there. So let's go and have a look and see where the dark blue is. That's those locations. Oops. Let's go there. Okay, so that's locations are all that location. That one there is this one there. So the small ones, there's one there. And again tells you how many of them falls within that, etc. So that one there. So this is sum of snow. So these are big snow areas. Is it giving me terrain there? Okay. Okay, so that is the bubble. Then there's a 3D scatter plot. Let's keep it sum, terrain, and minimum. Let's do that. There's a 3D plot of it. You can change the stuff a little bit, etc., etc. There's some cluster analysis you can do. This is also quite interesting. You can do a principal component analysis. So where's my snow sum? There's my snow sum. I can do components. I'll standard, and I can run. Oops, check if the data is valid. Components. Why is it not giving me components? Oh, sorry, I must choose a max medium. Okay, so there's the components that I've done. So you can do cluster analysis, as I said, by k-means, all spectral cluster analysis. Some of them, there you go. A number of clusters, let's say 4, and run. So that gives you the clusters analysis, etc., and some information there. So you can do cluster analysis. But what I normally do is, I look at space. This is where I start getting excited about GeoDa, is when we do univariate local Moran-I statistics. There's a couple of others. You can work with it. Spatial correlation is distance scatter plots important, but let's just quickly go there. So I'm going to use my snow sum, and you see there's the weights. There's where the weights comes in. It automatically uploads the weights because it's now assuming near things are. So locations close will have snow. Locations far from my opposite. There we go. And I want all 3 maps. Okay, that's okay. There's 3 maps. Sorry. Okay, so there's the 3. Let's put it this way. So there's the Moran-I statistic, 0.75. There's the Moran-I statistic. Okay, and you'll see, oops, that we did it. Moran is 0.758. That means that locations have a definite influence. There's a spatial relationship that the closer things are more correlated than distance things. That's what the Moran-I statistic presents. Okay, so it does indicate quite a high spatial correlation. Okay, so locations that have snow most probably will be close together. Locations that don't have snow will be located together. So that's very important there from a spatial point of view, that number there. Then if we look at the clusters, remember there's your high cluster, low cluster, low, high. And you can see there, interestingly, the high snow cluster is around this area. Okay, the high low cluster, you see the low clusters. So high is where there's definite snow, for sure. Low where there's definitely no snow. And these others, the low, high, low, are areas that maybe. But what we're interested in is the definite yeses and the definite no's. So the red, definitely there will be snow. The blue, definitely there won't be snow. And this is the significance map. You can see this high cluster here. You can see it's very high statistically significant, P0.001. You can see some of these no clusters as well are very high. So in general, if you look at the Moran statistics, you look at the clusters and the significance of the cluster, you get a picture of where there's potential, where there's going to be snow, where there's definitely not going to be the snow, the cluster area of snow, and that snow is statistically significant. So that to me is very, very nice work and very, very interesting stuff. It gives you the spatial structure of your data, the spatial nature of your relationships. It gives that 3D element if you want to. It's space and time, which we call the star type of model, spatial time autoregressive moving in average models. So that's interesting, very, very, very interesting. And you can play around. There's cluster maps. Same thing when we do that. And then obviously we can do regression. We can do spatial. Remember in R, we just did a standard cross-section or time series regression. Okay, but we didn't bring in space. Here we're going to do that same regression, but we're going to bring in space. So let's do the same one. Remember we did in R, let's just go there. We said that it is snow is minimum temperature, slope, and hillside. Okay, so let's go there and say that our snow, okay, and we said it is minimum temperature. Okay, so that's our dependent variables, our independent minimum temperature. We have the mean, and then we had, what did we had still? We had slope and hillside. So we had slope, remember slope is 2, and hillside. Okay, so first we're going to not add in the weights, we're just going to do classic and we're going to run. And we should get the same value. So median is minus 21. Have a look there. Ah, come on, it's not that. Wrong buttons. You can see the intercepts are different. Medium, the mean temperature is 0.777. And here, the medium, it is minus 21. The minus is still there. Still statistically significant, etc. You can see that's still. So those are all the same, but you can still see hillside is still significant. So in general, it's the same thing. Just the coefficients vary a little bit, but the numbers are, the model itself are exactly the same. You see there's adjusted R square 0.43. Let's go ahead, adjusted R square 0.43. So in essence, it's exactly the same thing. Okay, so we just basically run this regression that we did in R. We just ran that in GeoDa. Okay, so that being said, now the important part. Let's say we want to include the weights. So we're going to include the weight, and therefore we're going to run the classical again. Done. Let's see. It's going to be done. Still the same. It didn't include the weight. The classical one didn't include. So what we have to do is do the spatial weight, the spatial lag. Run it. And you'll see what we will get is we'll get some other variables. Now what we're interested in now here is to determine, and it will give you a statistic. It will tell you, it will give you in the, it will tell, where is it now? It will give you a value to determine whether the, you can see unfortunately the hillside, okay, so sorry, there's the weight matrix, there it is. And this index, you see the hillside is still not relevant. Now the rain and medium also are becoming, you see that they're also becoming statistically insignificant, but the weight matrix is statistically significant. You can see that, and quite high. So nearby neighborhoods have quite a high impact on one another, high influence on one another. But these others are now have become statistically insignificant, and we can test the whether that weight matrix is statistically significant or not. We can do it. We do the spatial error one. We can run it again. There is my lambda, which is my spatial. Remember the spatial lag is, it basically adds a lag value to the y dependent. So that will be now snow lag. So when we do the spatial lag, this one here, okay, it will be a spatial lag under dependent variable. So where the classical variable, classical is snow, is equal to, what was it, rain, what was it again? Snow is equal to minimum temperature, slope, and hillside. The spatial lag will now include here a snow spatial lag variable. Okay, so that's what it generates. It generates a spatial lagged variable. Here it creates, remember, you have an error term. It's there normally, there's an error term there. So this one, this method creates and then you can also do a spatial x of the x variables, but that is in a different program, in the spatial error, which is lambda here. You can see it's again statistically significant. Now minimum temperatures is still significant, but the rain and hillside becomes not statistically significant. But in both cases, the spatial lag of snow is statistically significant, and the spatial error of the model is statistically significant. And you can do those sort of calculations. And you can obviously expand on the model, and this is again where your weight matrix is coming important, okay, because that result is based on this weight matrix. So you add another weight matrix, you may get different results. That's why it's always do 2 or 3 weight matrices and have a look. The results are the same, then you are comfortable, your spatial weight matrix is correctly specified. If they are very different, then you have to make a call which of the spatial matrices do you think is the most correctly specified. Anyway, again, it's just an idea what you can work with. Okay, so that's the beauty of GeoDa. You can do spatial work in this program, and specifically relating to the spatial nature of the relationships, if at any, between these locations. And that adds a 3-dimensional view to it. So you're not just looking where the time is important, whether where the time is important, but also whether the relationship between the locations are important. And that's quite neat. So that's GeoDa. Yeah. So as I said, another niche area, another nice amount of features and that you can do in GeoDa that brings the data to a different light. It puts the data in your region of interest in a different light. And that's quite interesting. Spatial nature of it, which you can't do in Excel. And in R you can do this. In RStudio you can do it, but it's a little bit more tricky. But you can do it. But I like GeoDa. Beautiful little thing. Quick. Okay, thank you guys. Much appreciated. Thanks for your company. I hope you enjoyed it. I hope you find it interesting. And play around with GeoDa. You'll be very surprised on the power of it. Neat little package. And please like and subscribe. Please share the video. Please spread the word. We are here. The journey is going strong. And thanks for your company. And I'll see you on the other side.